Number 78, and it said that the distance north of the restaurant was given by 2t squared minus 7. Is that right? So in this problem, they don't have you graph until the end, like part E or part F. But I'm going to really, as I'm answering the questions, I'm going to be using the graph the whole time to go along with the calculations. Okay. So question A is, so if we were graphing this, which quantity would go on the horizontal axis? Would it be the time since started driving, or be the distance from the restaurant? Time. Okay. And so that is, I kind of meant to show you this on Wednesday as part of my the little talking about pathways in general, but we can use it today. All right. So time, our quantity 1 is going to be time since started driving. Since Bob started driving. In seconds, right? Okay. Would it be okay if everything will be the same? Which is, I wanted to make things a little clearer on the graph. I'm going to change it to t squared minus 7. Is it okay? I think everything will be this. Just the final answer numbers will be different, but as we know, it's all this reasoning and the thinking about it that's the most important thing. So I'm going to change it to t squared minus 7. So if you're taking notes, make sure you note that I'm going to do a slightly different version of the problem. Okay? All right. So is this the time since Bob started driving? Remember day 1 and 2. Is this a changing quantity or a constant quantity? The time since Bob started driving in seconds. Changing, right? So it could be 1 second since he started driving. It can be 5 seconds. And so, like you said, we represent that on the horizontal axis as an increasing quantity, right? So starting here at 0, 1, 2, 3, 4, 5, 6, 7, 8 seconds since leaving the restaurant, or since starting to drive. Okay, then what's our other quantity? Okay, so so exactly what distance are we talking about?
Distance from the restaurant in feet.
Okay, so distance, and specifically distance north. So at time equals 0, what's the distance north? So x squared minus 7. At this start, when no time has elapsed, what's the distance north of the restaurant? Yeah, and what does that mean? So that, and then that's also the question. The first question, part A, was at 1 second you also get a negative distance. What's that about? Yeah. Okay. So if t equals 0, then we get d equals negative 7. If t equals 1, we get d equals negative 6, right? So a negative distance north of the restaurant then would mean south of the restaurant. Okay?
But he didn't leave the restaurant.
What's that?
But he didn't leave the restaurant yet, so I marked it as 0.
I saw it as like 6 seconds until we started leaving.
Okay. Yeah. So.
But that makes more sense.
Yeah. So if we really want to take, if he started driving at 0, then hopefully he's not still in the restaurant, right? Yeah. So he would be south of the restaurant. Okay. So what happens as time increases? What happens to the distance north of the restaurant as time increases? It increases as well. And so this is the idea that they're increasing together, right? They're increasing together. And so if we just stop, say here at t equals 5, then we plot that as a point. And that represents this time of, at time equals 5, the corresponding distance from the restaurant is something like 17 or 17.1. Okay? Well, we can calculate it. So what is 5? So it would be 17, right? So 5 squared minus 7 is 18. 18. And then we saw that if we want to take all the points that represent the time since he started driving and the corresponding distance north of the restaurant, and we want to look at all the points at once, that's what we call a graph, right? That's what we call a curve or a graph. So that's the result of how these two quantities change together. That's every point of time since Bob started driving and the corresponding distance north of the restaurant.
What about when it says like for B, when it's T equals 3
Uh-huh.
and to T equals 5, do you put in both numbers and then just like
Yeah, so
average?
let's do B. Yeah. Okay, so here is, I'm showing here what's happening at T equals 3. And then we're really thinking about a dynamic situation here going from T equals 3 to T equals 5. So it's like we're considering this situation going from T equals 3 to T equals 5. Oh no, here's 3, sorry. From 3, there's 3, sorry. From T equals 3, sorry. From T equals 3 to T equals 5. That's what part B is talking about. When time changes from 3 to 5, there's a corresponding change in distance. So what does it ask? It asks for the average speed over that time interval. Is that right? So average speed is, we're all experts. What is it first and foremost? And that's how you calculate it, but what is it? It's the constant speed to do what? Travel the same distance. So we know our constant speed formula is the change in distance over the change in time. So let's start with the easy part, which is the change in time. So in this situation, what's our change in time?
5 minus 3.
Right. Okay. So it's from 3 to 5. How much change in time is that? 2. 5 minus 3. Okay, so now I'm going to take 2 and put it into here to get the change in distance, right? So I'm going to take t equals 2 and put it into the distance formula to get the change in distance. Is it right? What would that mean if I took 2? What would I be saying I want to find if I took the value 2 and put it into this equation?
Distance traveled over the 2 seconds.
Over which 2 seconds?
From 3 to 5. Well, I need 2 seconds.
What is D? D is the distance north of the restaurant at time t. So if I put 2 in there, what am I telling it to do?
That times 2.
If I put 2 in there, what I'm talking about is this point. I'm talking about that point. I'm going to get what? -3, or 3 feet south of the restaurant. Is that the change in distance as I go from 3 to 5? Okay, this is the most common student error. They take that change in time and they say, oh, then the change in distance is just what I get when I plug 2 in. But it's totally different, right? If I plug 2 into that formula, I'm getting this point. I'm getting at 2 seconds, what's the distance from the restaurant? Totally different than how much the distance changes over those 2 seconds. Do you see?
It still changes 3.
What's that?
It still changes 3.
Does it change 3?
Oh, 4. Excuse me.
Okay. So the ordered. So we have this ordered pair. 2, comma, -3. And what does that represent?
A point.
In the context of the problem, it means that at
2 seconds.
2 seconds since started driving, 3 south of the restaurant. Okay, that's what that means. So how are we going to get what we really want is yeah. So what we need is we need the distance traveled at 3 seconds And we need the distance traveled at 5 seconds. So how can I, first of all, in this picture, how can I represent the delta t? How can I represent that delta t? We've practiced this. No, how in the picture, what can I do in the picture to represent a change in time of 2? Remember doing this? So we've been practicing this a lot. Horizontal line of 2. That's our delta t equals 2. So then what in the picture is going to represent our delta d? The corresponding change in the distance best line of the semester. How do we find that change in distance? It's a far cry from 3, right? It's a far cry from what you get when you plug 2 in. It's a lot greater distance. So someone here was saying what we're going to do. How are we going to do this? So how are we going to get that change in distance? Volunteer? Yeah.
D when the time is 5 minus D when the time is 2.
Yeah. So what is the time, or what's the distance at 3?
2.
2. And what's the distance at 5? 18. Change in distance? Totally different, right? Totally different than plugging 2 into the distance formula. So you really got to know, or the distance formula. So you really got to know what you're doing, what different things mean, so that we have it. So now we've got.
Is that what that 2 coefficient is for?
What's that?
That 2 that was originally in that formula, does that make up the difference that's missing? Is it, or is that wrong? I'm just asking, you took the 2 off of the distance formula before we started.
Okay.
Does that, because that, if you were to plug that, if you were to plug the 2 that you found from the changes.
It would be even more different. So me changing this formula has nothing to do with why these are different. Nothing to do. Okay? It's because the meanings of these values are so different. That's what it is. Change the formula and you have the same scenario. Does that help? Yeah, so it's really about what's the meaning of that and what's the meaning of this. They have 2 totally different meanings. Okay, so it's 16 over 2. Average speed, 8 feet per second. So from time equals 3 to time equals 5, Bob drove 8 feet per second for those 2 seconds. Is that right? Oh, question.
Is there a 2 in the original formula?
Yeah, I changed it. So I changed the problem. Yeah. Okay, so Bob went from time equals 3 to time equals 5. Bob went 8 feet per second for those 2 seconds, right? People are nodding, right? Is that what happened? Still more nods. For those 2 seconds, he went 8 feet per second for those 2 seconds.
No. Well, no, that's just his average speed.
That's his average speed. Did he travel at a constant speed?
No.
No, he's speeding up, right?
Yeah.
He's speeding up. So what does that number mean then? If the average speed, and what's the average speed?
It was a straight line in between. It goes constant.
If he were going at a constant speed, this is the one he would have to go in order to cover that distance of 16 in those 2 seconds. But he did not. His speed was speeding up. So visually on the graph, that 8 feet per second, this is going to be hard.
16.
This is going to be hard, but imagine a line there. Yeah, imagine. A line there would represent the 8 feet per second, a constant speed. But you see there, it's slightly curved. He's speeding up over those 2 seconds. So again, it's the constant speed needed to go those 16 feet in those 2 seconds. Okay, does it make sense? Yes?
I have a question. Can't you just take the 2 and plug it into the formula, and then do the same thing with the 5 and take the difference between them, and that will give you your same
No, if you plug the 2 into the formula, you're going to get how far from the restaurant.
And then you do the same thing from the 5 and take the difference between that.
No, then that would be calculating the change in distance from 2 seconds to 5 seconds. We're going from 3 seconds to 5 seconds.
Okay, well, I don't have my homework, so whatever the given numbers are, I mean, that's what they told me I could do in the tutor center. So that's what I did. I mean, I don't have my homework, so I can't really remember the exact answer.
If you plug in 2 and get the distance and 5 and get the distance, what you're doing is you're finding the distance traveled starting at 2 seconds and ending at 5 seconds. That's what you're doing there. Okay? But you don't want to ever plug the change in time into that formula if that's what you're trying to do. That doesn't work. Doesn't make sense.
Okay.
So does it help?
I mean,
I'm not sure about why do you want to plug 2 in and then 5 in. Why do you want to plug 2 in?
That's just what they told me I could do.
You gotta understand why you're doing it though. So why?
Because if you're plugging in those 2 times, so you're finding what your distance.
What 2 times do you want to plug in?
I mean, I don't really know the question. I don't have my homework in front of me, but if you're plugging in the 2, and then you're finding not distance, and then you plug in the 5, and you're finding not distance,
Yeah, it's the
and
same
then
thing
you
you did.
subtract them.
I think you're just forgetting what the problem was. The problem was from 3 to 5, not
Okay, so
2 to 5.
3, sorry.
Yeah, that's what we did.
Plugging in 3.
Yeah, we plugged in 3 and we got 2, and we plugged in 5 and we got 18, and we took the difference. 16.
Okay.
Yeah. So I think we're saying the same thing. But plugging in 2 first would be a different problem. It'd be
Yeah.
starting at 2 seconds
Yeah,
instead of 3.
sorry, I didn't
Yeah.
have it.
Yeah. Okay. Okay. What is? What's the next thing? What's part C? Okay, so now we're experts at that, right? So C and D, piece of cake. How are we going to get those distance? So say from, yeah. So that's even less work than B. So in B we did more. We included what you need to do in C and D in order to do B, right? You're just finding this part. So in C and D you're just doing the same process for a different time interval, and you're just finding the change in distance. Okay. So I think you can do that. All right, so how much time did it take to travel from 20 to 30? So we'll do something different. We'll do from 5 to, so if I want the distance to go from, say, 5 to 20, what am I going to be looking at here in this illustration to see the distance changing from 5 to 20? The blue arrow or the pink? Pink arrow. I'm going to start at 5, if I can. That's the best I can do, okay? So we're going to start at, and 5 is the x-coordinate or the y-coordinate? So I want to know, going from 5 to, where did we put that? Sorry. Say 5 to 21. So how is that change in distance from 5 to 21? So that's, what change in distance is that? 16 feet, right? How can I show that in the picture? How can I show that in the picture? With a point? What do you want to do? Vertical line. Oh, I was doing good. Okay. Our delta D now is 16. This corresponding change in time, so what is it? We got D equals T squared minus 7. So I'm going to put 16 in for D, and I'm going to solve for T, and that'll give me this corresponding change in time, right? I'm going to take the 16, put it in for D, and solve for T. Does it work?
You put the change in distance in the distance?
Oh, am I trying to put a change in distance into the distance formula? Am I trying to do that by putting 16 there? Yeah. So is it right? It's not right. This is what students do. They say, oh, my change in distance is 16, so if I just put that in there, it'll give me the corresponding change in time.
It'll tell you where it hit 16.
That's right. It'll tell you the time to get 16 feet north of the restaurant, but that's not this change in time, right? So same thing, what do we need to do?
Plug in 21.
Right, we got to plug in 21 for D and get T. And we got to plug in 5 for D and get its time. So I think T here is square root of 28. What is that approximately?
5.2915.
Perfect, 5.3. Okay? And square root of 12. Anybody?
3.4641.
3.5. So, by plugging 21 into the distance, we get the time that it took to get to 21 feet north of the restaurant. And then by plugging 5 in, we get the time to get 5 feet north of the restaurant. What's the change in time?
1.8.
Remember, the change in time will be represented by this horizontal line. 5.3 minus 3.5 is 1.8. And let's just for kicks, let's put 16 into this, and what do we get? So if you were to put 16, do it in red, and we'll compare it and see that it's something totally different.
4.795.
Yeah, so 16 equals t squared minus 7 gives us 4.8.
Yeah.
So what is that? That means if I'm 16 feet north of the restaurant, at what time did I reach that? You see? 4.8. And that's totally different than what we wanted, which was the difference in time to get from 5 feet from the restaurant to 21 feet.
So you can, okay, so this is, you can find, you give it a couple of values, you can find the other values and still do your changing.
That's how you have to do it. That's how you have to do it. If you put a change in distance in here, it's going to think it's a distance from the restaurant, not a change in distance.
I can either find a specific change in time, or I can find 2 points and find, I said that wrong. You can find a specific point in time, or you can find 2 separate points in time and then find the
Right.
change.
In order to get a change, you're going to need to know what those 2 different time values are to get the difference.
Okay,
That's right. That's right.
that makes sense.
Okay. But if I plug 16 into this, it thinks I'm saying that this D represents 16 feet north of the restaurant. So it's going to tell me the time it took to get 16 feet north of the restaurant. Totally different from the change in time that we wanted. So that's why it's in red, right? That's why it's in red. Don't do that, because that won't be right. Okay. More questions about this one? Let's see. So we already sketched some graphs here. Okay, so your workbook for Monday will be starting Module 3, and we'll start Module 3 on Monday. And then I will post, like I said, I'll post written homework for Wednesday. They should also start this weekend. Definitely start that this weekend. Okay, have a good weekend. Oh. Hold on 1 second. Did everyone get their homework? Did everyone get their homework? Graded homework? You couldn't find yours?
I ran it on Friday.
Oh, that's why. Okay. So it didn't make it into the stack.
But
So-
I get a score somehow.
What's that? Yeah, so
Thank you.
let's ask him. Let me turn this off. Hold on.